5782, which is true regarding minimum control airspeed while thermaling. Minimum control airspeed? A. May coincide with minimum sink airspeed. B. Is greater than minimum sink airspeed. C. Never coincides with minimum sink airspeed. The correct answer is A. The minimum control airspeed is the slowest airspeed at which a glider can maintain control. This is the speed at which the airflow over the control surfaces is sufficient to create lift and drag. The minimum sink airspeed is the slowest airspeed at which a glider can fly without losing altitude. This is the speed at which the lift created by the wings is equal to the weight of the glider. In some cases, the minimum control airspeed and the minimum sink airspeed may coincide. This is most likely to happen when the glider is flying in a thermal, which is a rising column of air. The rising air provides lift to the glider, which allows it to fly at a slower airspeed without losing altitude. However, the minimum control airspeed and the minimum sink airspeed are not always the same. The minimum control airspeed can be higher than the minimum sink airspeed if the glider is flying in turbulent air. The turbulence can cause the glider to lose altitude, even if it is flying at its minimum sink airspeed. It is important for glider pilots to be aware of the difference between the minimum control airspeed and the minimum sink airspeed. This will allow them to fly safely and efficiently. 5785. Regarding the effect of loading on glider performance, a heavily loaded glider would A. Have a lower glide ratio than when lightly loaded. B. Have slower forward speed than when lightly loaded. C. Make better flight time on a cross-country flight between thermals than when lightly loaded. The correct answer is C. The velocity at which the optimal glide ratio is attained rises as the glider's weight decreases. Only the airspeed at which the maximum glide ratio is obtained is impacted by weight. 5786. When flying into a strong headwind on a long final glide or a long glide back to the airport, the recommended speed to use is the A. Best glide speed. B. Minimum sink speed. C. Speed to fly plus half the estimated wind speed at the glider's flight altitude. The correct answer is C. When flying into a strong headwind, the glider will lose altitude at a rate equal to the difference between the speed to fly and the wind speed. By flying at the speed to fly plus half the wind speed, the glider can minimize the amount of altitude loss and reach the airport as quickly as possible. The best glide speed is the speed at which the glider can travel the farthest distance with the least amount of altitude loss. However, this speed is not always the best speed to use when flying into a headwind. The speed to fly is the speed at which the glider can fly into the wind and maintain altitude. Here is an example. Let's say the glider's speed to fly is 50 miles per hour and the wind speed is 10 miles per hour. The best speed to use to reach the airport would be 55 miles per hour. This will allow the glider to make the most of the headwind and reach the airport in the shortest amount of time. It is important to note that this is just a general rule of thumb. The actual best speed to use will vary depending on the specific glider, the wind conditions, and the pilot's skill level. 5787. Which procedure can be used to increase forward speed on a cross-country flight? A. Maintain minimum sink speed plus or minus 1/2 the estimated wind velocity. B. Use water ballast while thermals are strong and dump the water when thermals are weak. C. Use water ballast while thermals are weak and dump the water when thermals are strong. The correct answer is B. Water ballast is used to increase the wing loading of a glider. This makes the glider sink faster, which allows it to reach the bottom of thermals more quickly. When the glider reaches the bottom of a thermal, it can then climb to a higher altitude and continue its cross-country flight. When the thermals are weak, the glider will not be able to climb as high. In this case, it is beneficial to dump the water ballast. This will reduce the wing loading and allow the glider to fly at a slower speed, which will help it to conserve energy. 5788. The reason for retaining water ballast while thermals are strong is to A. Decrease forward speed. B. Decrease cruise performance. C. Increase cruise performance. The correct answer is C. To maintain the same glide ratio as the glider's weight rises, the velocity must also rise.